So let us see the equation for position velocity relation by graphical method. Actually, I had done this in the last video, but what happened was it was half done, okay, due to my carelessness, okay. So I am doing it once again. So here we consider what you can say an object moving with initial velocity u represented by OA, okay, with uniform acceleration it moves, so it is a straight line, and in a time interval of t seconds represented by OC, its velocity becomes v. Final velocity is represented by BC, initial velocity by OA, time is by OC. Now we have drawn AD perpendicular to BC. If AD is perpendicular to BC, then this OADC becomes a rectangle. So OC is equal to T, then AD is also equal to T. Now see, the distance travelled by the object is given by the area enclosed under the graph. Okay, so distance travelled S is given by area enclosed under the graph, that is OABC. Okay, distance is given by the area OABC, and OABC is a trapezium. Okay, OABC is a trapezium, and in this trapezium OA and BC are parallel lines, and the perpendicular distance between them, that is H, is given by OC. So area of trapezium is equal to half, is into H. H is the perpendicular distance between the two parallel lines. A and B are the two parallel sides or parallel lines of the trapezium. Okay. So now distance S is equal to half H, perpendicular distance between the parallel lines is OC, and the parallel sides are OA and BC. So OA plus BC. So it's equal to half into OC is what? T. OC is T. OA is U. Okay. And BC is, full BC is what? V. But V is equal to U plus AT. This is the first equation of motion. So V minus U should become equal to AT. So T should be equal to V minus U upon A. So in place of T, we will write V minus U upon A. So S is equal to, I'll write it again. Okay, it has been written again. No problem. I'll continue from here. Half T is what? V minus U upon A, and U plus V as it is. Now V plus U into V minus U, that is A plus B into A minus B is A square minus B square. So it will be V plus U into V minus U is V square minus U square upon this 2 into A. This 2 into A cross multiplies to the left side. So what you get is 2AS is equal to, on the right hand side what remains? V square minus U square. So 2AS is equal to V square minus U square is the third equation of motion, which is obtained by graphical method. So the three equations of motion obtained by graphical method are: first one is V is equal to U plus AT. Second one is S is equal to UT plus half AT square. S is the distance travelled. U is the initial velocity. V is the final velocity, A is the acceleration, T is the time. So first equation of motion is V is equal to U plus AT. Second equation of motion, S is equal to UT plus half AT square. Third equation of motion, 2AS is equal to V square minus U square. So we will solve example 8.5 from the text, and example 8.5 is on page number 108. I will read the question A train starting from rest attains a velocity of 72 kilometers per hour in 5 minutes. Okay, it has started from rest and attains a velocity of 72 kilometers per hour in 5 minutes. Assuming that the acceleration is uniform, find the first one, acceleration, and second is distance traveled by the train for attaining this velocity. Okay. Now let us see the solution. Since the train has started from rest, okay, its initial or starting velocity is 0. So initial velocity u is 0 since it has started from rest. And final velocity v is, it has attained a velocity of 72 kilometers per hour. So final velocity is 72 kilometers per hour. Final velocity denoted by v. So v is equal to, let us convert this into meters per second. 72 kilometers. Every kilometer is 1000 meters. So kilometer I have written by 1000 meters. And per hour, every hour is 60 minutes. Every minute is 60 seconds. So hour we are converting again into seconds. If you cancel this, you get v is equal to 20 meters per second. And time they have given as 5 minutes. 5 minutes means 5 into 60. That is 300 seconds. And you know, acceleration is rate of change of velocity. A is equal to v minus u upon t. Final velocity is 20. That's what you have got. Initial velocity is 0. Upon time is 300 seconds. 20 minus 0 is 20 upon 300. 1 0 1 0 cancels. 2 1s are 2 15s are. So acceleration is 1 by 15 meters per second square. Unit of acceleration is meters per second square. Now let us calculate the distance traveled. Now to calculate the distance traveled, let us see which formula to use. You know, final velocity we have is 20 meters per second. Initial velocity u is 0 since it has started from rest. Acceleration we have calculated it to be 1 by 15 meters per second square. So we have to calculate the distance traveled s. You know v, you know u, you know a, you have to calculate s. And which is the equation which involves all these v, u, a and s. The equation is third equation of motion. That is 2as is equal to v square minus u square. So s is equal to what? V square minus u square upon 2a. Let us substitute the values. Okay. See, v is what? 20. So v square is 20 square. U is 0. So u square is 0 square. Upon 2 as it is. Acceleration we have got 1 by 15. So 1 by 15 I have written. 20 square is 20 into 20. 20 into 20 is 400. Okay. So 20 into 20 is 400. Minus 0 square is 0. 2 ones are 2 upon 15. 400 minus 0 is 400. 2 remains as it is down. Denominator of denominator 15 comes up. If you cancel this, 2 ones are 2 200s are. So 15 into 200 is 3000. So the answer is 3000 meters or 3 kilometers. This is the answer for the question. Please understand the question, take down the notes in your fare and practice and revise them. Revise and practice them by writing them without looking.